This is lab 3, where we analyze the gravitational effects of a black hole. So coming to the overview, this lab is divided into two major parts. The first computational model finds the mass of a black hole through iterated computation of the net forces acting on the system. And the second part is a computation model where we determine a spaceship velocity such that it does not crash into the black hole, and this black hole is being orbited by the planet the spaceship left from. In this entire lab, we use three main physics concepts, the first two being Newton's second law and the momentum principle to calculate all the forces, and Newton's law of universal gravitation as we are dealing with celestial bodies. We go into part 1, which is finding the mass of a black hole. So we already have constants, which is the mass of the star, and delta T, which is both on the screen. And then again, the physics concepts we use is the gravitational force formula and dividing F net into its two components, F parallel and F perpendicular. And here you can see the code and how I have come to find the mass of the black hole in the calculation loop. So you find F net, which is equal to dp dt, find its parallel and perpendicular values, and then the mass of the black hole is found through rearranging the gravitational force formula. And here is a video of the trajectory of the star around the black hole. You can see all three forces, which is F net, F parallel, and F perpendicular in three different colors, and you can see the entire trajectory here. Part of the lab, which is spaceship crash prevention. So one important thing to note is that we use the mass of the black hole from part 1 to compute these calculations, and then I also tweaked the spaceship velocity through trial and error so it wouldn't crash into the black hole, and the values I used are up here on the screen. So here is the code that I used to find the net force on the planet and spaceship respectively. The planet has the black hole acting on it and the spaceship acting on it. I added those two to find the F net on the planet, and I used a similar computation for the spaceship. So here you can see the spaceship trajectory screenshots. The spaceship is in purple and the planet is in blue. So you can see that the spaceship went really close to the black hole, but it did not collide with it. And yeah, and the one on the right is the completed computation. Now getting into the analysis and answering questions about the two parts of this lab. So the first is discussing the difference between F net and rate of change of momentum and its relative components. Semantically, the force and its components act on the system. They are forces that act on the system, whereas the rate of change of momentum is a representation of the effect these forces in the system have on the bodies in the system. So that is the main difference between the force and rate of change of momentum. And for the second part of making the spaceship orbit the black hole, I did this by making the spaceship speed similar to that of the planet, however, not letting it collide with it, so its orbits aren't the same. And I did this through trial and error. And this next slide, you can see how their trajectories are similar but are not crashing into each other, but they're both orbiting the black hole. And that is the end of lab 3.